Alright, so let's integrate t minus 2 all over t minus 3 times radical 2t minus 4 plus 2 dt. So the first thing that I'm going to do right off the bat is I'm going to begin our u substitution, and I'm going to let u equal radical 2t minus 4. I'll square both sides so that I have u squared minus u squared is equal to 2t minus 4, and then I'll bring the 4 onto the left side of the equation and divide both sides by 2 so that I'm left with 1/2 u squared plus 2 is equal to t. Now I'll differentiate both sides, and what you're left with is u du is equal to dt. And now we're ready to plug back in all of this information, particularly the right side that we've just calculated. And when we do that, we find that our equation is now the integral of 1/2 u squared plus 2 from this t minus 2 all over 1/2 u squared plus 2, which we get from this t, minus 3, and remember we set our u equal to 2t minus 4, so minus 3u plus 2. After we simplify this a little bit, what we're left with is the integral of 1/2 u cubed all over 1/2 u squared minus 3u plus 4 du. And I'm going to go ahead and multiply the numerator and the denominator by 2, so that what I'm left with is the integral of u cubed all over u squared minus 6u plus 8 du. And it's at this point that we want to perform long division, which I've actually written out over here. And what we're going to do here is we're just going to we're going to keep u cubed here, and then it's going to be divided by u squared minus 6u plus 8. And after all of the long division is done, you get u plus 6 with a remainder of 28u minus 48. And I've noted that over here, by putting what we got from the division right here, u plus 6 plus our remainder 28u minus 48 all over what we were originally dividing by, the u squared minus 6u plus 8. Now what we can do is we can go ahead and factor the denominator so that we have u minus 2 times u minus 4. And once we do this, we'll be able to use partial fraction integration to solve this integral once we take apart this and split it into 3 integrals. So we'll worry about these two later. They're not difficult at all. But we set up our partial fraction integration such that the 28u minus 48 over u minus 2 times u minus 4 is equal to some value a over u minus 2 plus some value b over u minus 4. Multiply both sides by the denominator of this, of the left side of the equation, and what we're left with is 28u minus 48 is equal to a times u minus 4 plus b times u minus 2. And now I'm just going to let u equal 4 so that I can solve for b here, and when I plug everything in, I find that b is equal to 32. And when I let u equal 2, I find that the value of a is equal to negative 4. Given all this information, I can now plug our values of a and b back into these two fractions. And I've taken the liberty of splitting the integrals, the u plus 6 plus our fraction here, and I've split them into 4 integrals, 2 which came from this part of the problem, and the other 2 of which came from this part over here. And when we plug all that back in, we find that it is the integral of u plus the integral of 6 plus the integral of negative 4 all over u minus 2 plus the integral of 32 over u minus 4. And once we integrate all of these individually, our answer turns out to be 1/2 u squared plus 6u minus 4 times the ln of the absolute value of u minus 2 plus 32 times the ln of the absolute value of u minus 4 plus c. And now our final step is to just plug in our values of x. And actually, I made a mistake here. So we want to keep it in terms of t, not x, which is what our original equation was in terms of. And when we do plug everything back in, we find that the answer is t minus 2 plus 6 times radical 2t minus 4 minus 4 times the ln of the absolute value of radical 2t minus 4 minus 2 plus 32 times the ln of the absolute value of radical 2t minus 4 minus 4 plus our constant c.